Hello everyone, welcome to another particular lecture. And in this particular lecture, we are starting with a very interesting and a new chapter. And this is a very important chapter for the people who are actually learning organic synthesis. And I personally like to introduce this particular chapter before starting reagent chemistry because this particular chapter has the importance to do in the reagent chemistry part. Okay, so in this particular chapter, we are dealing with some kind of different kind of protection and deprotection strategy for certain particular molecules. And this is a very much important for not the JAM people, but for the GATE and CSI net or kind of a MSc entrance people. This particular chapter is very important. And not only this particular chapter is important for the examination, but it will be important for the general purpose also, because if you need to learn organic chemistry, you should have to learn about the protection and reproduction group. Okay, so we are just begin with a very simple thing. Like first, let us talk about a little bit of context that why we need to learn the protection reproduction formula. Suppose you have this particular group which contains two different functional groups. Like here is the ester group is here and here is the carbonyl group is here. Now if you want to selectively reduce one of the particular reagent, okay, or particular group, so you need a certain reagent. Now what happened that we know or we learn in the reagent chemistry, or we knew in the reagent chemistry part, that for selective reduction can be possible by using certain reagent. But when in the practical approach, when you are doing experiment in the lab, it might happen that you don't have the availability of the particular reagent to do a particular chemoselective reagent to do this particular conversion. So what do you do? What the chemists do? So suppose you have only lithium aluminum hydride present in your lab, and you have to protect selectively one of the particular group, either the carbonyl center or the ester center. But you have only lithium aluminum hydride, and lithium aluminum hydride is a not selective reagent. It can reduce both of the group here. Okay, so what the chemists do actually? Chemists actually do to mask this particular carbonyl group, because we need to retain this particular group here, but we need to reduce this particular group to the corresponding alcohol. So what happened that the chemists do by some kind of chemical reaction, they marks this particular group so that this particular group is now become a non-reactive in presence of lithium aluminum hydride. So lithium aluminum hydride only reduct this particular group to forming their corresponding alcohol. And after a demasking pathway, like first we have to mask by certain chemical reaction, and after that we have to keep some kind of chemical reaction to demark this particular group to retain our desired functional group. Okay, and our targeted functional group has reduced to the corresponding alcohol. So this particular method is useful when might happen that you don't have the suitable reagent for the particular part, but you have to do your job done. Okay, so the main disadvantage of this particular process is you have to uh, go for a multi-step synthesis, but it will be very much useful and handy for the people who are actually working in the lab. Okay, so first let us talking about the definition of protection group. So the protection group is a chemical moiety that temporarily introduced into a molecule to mask a functional group and prevent it from participating in unwanted chemical reaction due to a synthetic sequence. Like in our previous example, here our interested functional group is the ester part, and the carbonyl part it is not interested part. So what happened that we are introduced on a temporary masking agent to protect this particular carbonyl group, which actually refrain the carbonyl group to undergo reaction with lithium aluminum hydride. And after demasking, we get this particular group back. Okay. So here also the definition suggests something like this, like prevent the unwanted chemical reaction during a synthetic sequence. And this particular protection group renders the functional group inert under the condition of the desired reaction. And after the completion of the reaction, the protective group can be selectively removed to regenerate the original functional group without affecting the other parts of the molecule. So it is a little bit of vast definition, but this particular definition contains everything regarding a protection group, protecting group thing. Okay. Now, not every group become a protective group for the every kind of um, a functional group. Okay, all any kind of random XYZ reaction we don't do to protect some kind of group. Okay, so the protective group my should have some characteristics. So some of the characteristic is the ease of introduction. The protective group should be easily and selectively introduced to the target functional group. Second one is the stability. It should be stable and inert under the reaction condition required for subsequent synthetic step. And the third one is the ease of removal. The protecting group should be removable under mild conditions. Okay, and another thing is when doing the removal, we should have to generate the product in the higher yield, like nearly 90%, 92%, 93%. Because since when we are adding a protection group in the our organic synthesis pathway, we actually move to a multi-step synthesis, and we know that as many as we increase the step, the yield are significantly reduced. So the ideal protecting group should have the capability to, while doing the deprotection strategy as well as the protection strategy, the reaction yield should be much higher. Then we can say that it is a, yes, it is a good protection group. Okay. Now different kind of functional group can be protected by this method, such as the amine protection, alcohol group protection, carbonyl compound protection, acid protection, and double and triple bond also be protected during organic synthesis pathway. Okay, so we initially began with our discussion with the amine protection. Now, several techniques for amine protection are the BN protection, CVZ acetyl protection, BOC protection, FMOC protection, alloc protection, and tosyl protection. Like different kind of protection strategies is there. Now you may ask that why we need this type of protection. Like if we know one type of protection, then it will be easy and our job is done. Our job is to simple protect the amine group. So why we read this much of protection? Because this type of protection having their own unique properties for the particular reaction synthesis pathway. Okay, and that's why actually this all the protection strategies have their own significance in the particular study. Like here, some of the protecting groups such as the BOC and CVZ group are mainly used for the protection of primary amine groups, whereas the FMOC and tosyl groups are basically used for the secondary amine protection group. So that's why all the protection technique we have to learn, and also all the protection technique having their own unique deprotection strategies, which actually the chemist will actually judicially take the protection group as per their requirement. Okay. Okay, so we initially began with our protection strategy with the simple thing. This is the BN protection. BN is stand for the benzyl protection, and it is usually suitable for uh, amine and alcohol group protection. Okay, so the reagent is the benzyl chloride or benzyl bromide. This is the reagent, and also we need some kind of base during the protection strategies, such as the sodium hydride or potassium carbonate or triethylamine base has been introduced to do the job done. And the reaction is very much simple. The primary amine react with the BNBR to form this RNHBN, and thus we actually protect the amine, primary amine group here. Okay, so what should be the deprotection strategy? The deprotection method is the hydrogenolysis, where the hydrogen palladium charcoal is used to break this particular NBN bond to regenerate our primary amine. Okay, now we are moved to our second protection, is the BOC protection. The BOC stands for the di-tert butyl dicarbonate group, and it is react with the primary amine to form a Bock protected amine. And the removal of this is the acidic condition, that is a trifluoroacetic acid. Like in the previous BN protection, we need hydrogenation, like H2 palladium charcoal is required to deprotection. So suppose you have one particular reagent or one particular reaction where after protection you have to do like hydro H2 palladium charcoal was used to do the selective reduction of the particular any kind of group. So in that particular part you don't use BN protection. That time you should have to choose the Bock protection. Okay, and this is commonly used for the primary amine. So this is the structure of Bock, and sometimes the Bock can be shown like this. Okay, so what should be the mechanism? So the mechanism is this particular lone pair of amine actually attack in the carbonyl carbon here, and this particular bonds goes up, and this goes down to remove this particular part. So here is the kind of amide bond has been formed, and this particular third butyl part, third butyl oxide part, will capture the excess hydrogen here. The hydrogen abstraction takes place, and to form this particular amide kind of bond is the protected form of the primary amine by using Bock. And after using the acid or trifluoroacetic acid to selectively cleavage this particular bond to get our desired primary amine. Okay. Now we are moved to the third protection strategy, that is the CBZ, that is the benzoxycarbonyl group. Okay, and the reagent is the benzoyl chloroformate. This is the our CBZ reagent or CBZ protection group, and the introduction is the react with the primary amine to form a CBZ protected amine, and the removal is similar like the BN protection where you can do hydrogenation, like hydrogen palladium charcoal or acidic condition is required to do the removal of the CBZ group. And selectively it is used for the uh, primary primary amines, but also it protects secondary amines. But it is more often used to protect the primary amine protection. Okay, so the mechanism is similar to the Bock protection, like this particular lone pair of amine attack here, and this particular group goes, this particular bond goes up and goes down to remove the chlorine part to generate this particular NH-CBZ group. This part is the CBZ part, and after doing the hydrogen palladium charcoal deprotection to return back our desired primary amine compound. Okay, so now we are begin with our next protection strategy, that is the alloc protection. So alloc protection is very important and interesting because the alloc group is a protecting group used primary for the amino acids protection in the organic synthesis. Okay, and the reagent for the particular protection is the allyl chloroformate. This is the our particular protecting group where this particular part is the alloc part, allyl chloroformate. Okay, so alloxycarbonyl part, this is the, and the overall molecule is the allyl chloroformate. And while doing the protection strategy, we often use such a base like triethylamine to neutralize the hydrochloric acid bipolar. Okay, so what should be the mechanism? So here the amino acid part is here. So similar like the previous CBZ catalysis part, or this CBZ protection. So this particular amine will attack here, and this particular bond goes up and goes down to remove this particular chlorine part to get our the alloc protection protected amine. And after that, we are using the deprotection strategy similar to the CVZ or BN protection, like we are doing hydrogenolysis to regain our deprotected form. Okay. Now let us move to the next particular protection strategy. There is the FMOC, there is the fluoronyl methoxy carbonyl group. Okay, so the reagent is FMOCCl. This is the particular protection group, and the removal of the particular group is the basic condition. The piperidine is required to remove the particular group, or we can say the deprotection can be done in the place of basic condition. And the selectivity, as we say, that it is often preferred to uh, selectively in the secondary amine protection over primary amine protection due to the bulky nature or due to their easy removal under mild condition. Okay, so the mechanism is similar to the previous part. Here the 2-degree amine or the secondary amine react to get this particular protected form, and where treated with the base or the piperidine, so this particular group getting deprotected, and we actually observe the deprotected amine. Okay, so another thing is the sulfonamide. It is also very much important. It is also particularly effective for protecting the secondary amines. And here there are the two variant is there in sulfonamide part, is the tosyl protection and the protection, or the methyl sulfonyl chloride protection. Okay, so the tosyl structure is something like this, whereas the structure is something like this. So it will getting protected, and also here is also we use some kind of base to protect this particular secondary amine, and strong acids such as the trifluoroacetic acid was required to cleavage this particular NTS bond to getting our deprotected group. Okay, so let us uh, do a quick summary of the amine protection. Like if you can't remember the previous everything, that you were just simply remember this particular slide, this will be enough for your examination purpose and all. So first we are talking about the primary amine protection. If you have a primary amine, so how can we protect? First you can take BNBR. The protection strategy is BNBR in presence of base to get the protected form, and for deprotection using the hydrogen palladium charcoal. Similarly, for the CVZ you can use CVZCl plus triethylamine for protection, and deprotection you can use the hydrogen palladium carbon. Bog protection you can use the Bog 2, and for deprotection we need acid condition, this is the trifluoroacetic acid. And there is a alloc protection was there for primary amine protection. This is specially alloc is used for the amino acid group protection, where the protection for give the alloc Cl, and the reproduction strategy is hydrogen palladium charcoal treatment. Now if we look for the secondary amine protection, here the acetyl protection is there. Acetyl protection, acid was used, or RCOCl was used for protecting the particular amine, secondary amine, and the deprotection strategy is use some acidic condition. Then FMOC protection, uh, FMOC was used for protection the secondary amine, and whereas the deprotection strategy suggests the basic condition was required, especially piperidine was required to do the deprotection. Then it's come for the tosyl protection. Tosyl chloride triethylamine is required to protect the tosyl to form the NTS bond, and the deprotection is the acidic condition, is the trifluoroacetic acid. Similarly, for mesetyl case also mesetyl chloride and triethylamine was required, and the deprotection strategy is same like tosyl, like a trifluoroacetic acidic condition was required. So with this, we have to end this particular lecture. So here in this particular lecture, we learned the importance of the protection group in the particular organic synthesis, and we learn about the amine protection in details. Now in the next class we are discussing about the alcohol and acid group protection. So thank you for listening.